Welcome to Basic Integration Facts, part 3 of your Calc 1 review. So just a quick review of the indefinite integral. The indefinite integral, which we write as an integral of f of x dx, is the set of functions of the form capital F of x, such that the derivative of capital F of x is our original lowercase f of x from the integral. So some basic integrals to remember, since the indefinite integral corresponds to a derivative fact, our basic integrals to remember will come directly from derivative facts. So we'll just do a quick run through of our derivative facts. And the corresponding integral. So our derivative fact, our power rule, derivative of x to the n equaling n times x to the n minus 1. The corresponding integral is the integral of x to the n dx is x to the n plus 1 divided by n plus 1. And then we have a plus c to incorporate all functions that give that as its derivative, that give x to the n as its derivative. Next up, we have our trig derivatives. Derivative of sine of x was cosine of x. So the corresponding integral is the integral of cosine of x dx is sine of x plus c. Our derivative of cosine of x was negative sine of x. This becomes the integral of sine of x dx is negative cosine of x plus c. So be very careful with your integrals with cosine and sine. Watch those positive and negative signs. They kind of go the opposite of what happened with derivatives. Derivative of cosine resulted in a negative. In this case, it's the integral of sine that results in a negative. Next up, we have our derivative of tangent of x, which was secant squared x. So the corresponding integral is the integral of secant squared of x dx is tangent of x plus c. Update my screen. Remember, integral secant squared x was tan x plus c. Next up, we had our derivative of cotangent of x was a negative cosecant squared x. So this corresponds to the integral of cosecant squared x dx is a negative cotangent of x plus c. The derivative of secant of x was secant x times tangent of x. So we have the integral of secant of x times tangent of x dx is secant x plus c. The derivative of cosecant x was negative cosecant of x, cotangent of x. Well, this corresponds to the integration fact of the integral of cosecant x, cotangent of x, dx is a negative cosecant of x plus c. Continuing on, we had our exponentials. The derivative of e to the x was just e to the x. This corresponds to the integration fact. Integral of e to the x dx is e to the x plus c. The derivative of a to the x was a to the x times the natural log of a. This corresponds to the integral of a to the x dx is a to the x divided by the natural log of a plus c. The derivative of natural log of x was 1 over x. This corresponds to the integral of 1 over x dx as the natural log of the absolute value of x. Moving from here, we'll go ahead and look at some of our inverse trig derivatives. So again, the derivative of tan inverse of x is 1 over x squared plus 1. So we have therefore that the integral of 1 over x squared plus 1 dx. Well, I forgot my plus c in the previous integral. That should have been integral of 1 over x dx is natural log absolute value of x plus c. And we have 1 over x, integral of 1 over x squared plus 1 dx as tan inverse of x plus c. The derivative of inverse sine is 1 over the square root of 1 minus x squared. So we have the integral of 1 over the square root of 1 minus x squared dx is sine inverse of x plus c. And finally, the derivative of secant inverse of x was 1 over the absolute value of x times the square root of x squared minus 1. I apologize, I have an extra little dot in here. So derivative of secant inverse is 1 over absolute value of x times x squared, square root of x squared minus 1, all in the denominator there. Therefore, we have, if we wish to take the integral of 1 over absolute value of x times square root x squared minus 1, all in the denominator, dx. This is secant inverse of x plus c. This is these are our main basic integration facts. that can be useful for taking integrals. So again, these primarily corresponded, or these directly corresponded to the derivative facts that we had already seen. We have our exponentials, logarithms, trig and inverse trig, and then of course just our basic power rule. In the next videos, we'll look into taking integrals and using these integration facts to take integrals.